Hello dear student. Today we'll be working on multiplying and dividing algebraic fractions. If we have n1 and n2 are two algebraic fractions where n1 of x equals f1 of x over f2 of x and n2 of x equals f3 of x over f4 of x. So as you can see here, to multiply them, we multiply the numerators together and we multiply the denominators together. And don't forget to get the common domain as we explained it before. Let's check an example. In this example, if f of x equals x plus 1 over x squared minus x minus 2, multiply to x squared plus 3x minus 10 over 3x squared plus 16x plus 5. The question is asking us to simplify this expression in the simplest form and to identify its domain. After that, the question also is asking us to find f of 0, f of negative 1 if possible. Let's go and check. How do we do it? First of all, we need to factorize any numerator or denominator we have. So, if we factorize this in here, so the x squared minus x minus 2 is factored into x minus 2 times x plus 1, and x squared plus 3x minus 10 is factored into x plus 5 times x minus 2, and this part is factored into 3x plus 1 times x plus 5. After that, before you cross out, before you simplify, you need to find the common domain first. So, in this case, the common domain will be all real numbers represented by r except 2, 1, negative 1 over 3, and negative 5. After that, we need to combine the numerators together and the denominators multiplied together. Before we start crossing out and simplifying numerators with denominators, we need to find the common domain. As you can see, the common domain here is all real numbers represented by r except 2, negative 1, negative 1 over 3, and negative 5. So, as we said, that the common domain is r except the negative 5, negative 1, negative 1 over 3, and 2. Now let's cross out and simplify. We have here the x plus 5 will be crossed out with the x plus 2. The x minus 2 will be crossed out with the x minus 2. The x plus 1 will be crossed out with the x plus 1. What is left for us is 1 over 3x plus 1. After that, the question wants us to find f of 0. F of 0, so we go to the simplified one or the original one, but first, simplified one is way easier for you. We go to the simplified one and we substitute each x by 0, so it will be 1, where we cannot substitute and find f by negative 1 as x equals to negative 1 is not in the domain. Let's move on, dividing algebraic fractions. Remember very well, when we studied how to divide fractions, we do the keep, change, flip. We keep the first fraction as it is, we change the division sign into multiplication sign, and we flip the second fraction. So here, as you can see here, we keep the first fraction as it is, we change the division sign into multiplication sign, and we flip the second fraction. That's why we call it keep, change, flip. And don't forget to get the common domain as we studied it before. Let's see an example. Example 2. If we have here x squared minus 9 over 2x squared plus 3x divided by 3x squared plus 6x minus 45 over 4x squared minus 9. We're going to factorize any numerator or denominator that can be factored. Okay, so here we're going to write the question. As you can see that this here in this numerator we took 3 as a common factor. If I factorize the first one, difference of 2 squares, so it's x plus 3 times x minus 3 over, and down here in this denominator I take x as a common factor, divided by, after I take here 3 as a common factor, I can factorize this quadratic expression by x plus 5 times x minus 3, and down here again another difference of 2 squares, 2x minus 3 and 2x plus 3. Before you do the keep change flip, you need to find the domain. The domain in this case is all real numbers except for the 0, the negative 3 over 2, and the positive 3 over 2. So the domain is 0, negative 3 over 2, positive 3 over 2. Yes, as you can see it here, don't forget the second numerator, as when we flip it, it becomes a denominator. Don't forget the second numerator, as when we flip it, it becomes a denominator. So we take this as well in the domain. So x is also in the ordered numbers except the negative 5 and the positive 3. So keep the first fraction as it is, change division sign into multiplication sign, and then we flip the second fraction. Let's now simplify together. See, when I simplify, the x minus 3 will be crossed out with x minus 3. The 2x plus 3 will be crossed out with the 2x plus 3. So what will be left up for you in the numerator is x plus 3 and the 2x minus 3, where in the denominator is 3x times x plus 5. And this is the simplest form of the function f of x. Example 3. The question again is asking us to simplify and find the domain. Here we have x squared minus 3x over 2x squared minus x minus 6 divided by 2x squared minus 3x over 4x squared minus 9. Think first while factoring, think first for the common factor or the highest common factor, and then factorize each of the expressions that we have. So in the first one, as you can see as a solution, we will take x as a common factor in the upper numerator, x minus 3, over, if we factorize this, it will be 2x plus 3 times x minus 2 divided by, we'll take x here as a common factor, and here difference of 2 squares, 2x plus 3 and 2x minus 3. Let's find the domain. Domain is all real numbers except, yes, negative 3 over 2, 3 over 2, and 2. Keep, change, flip. First fraction as it is. Change division sign into multiplication sign, and then flip the second fraction. Now start crossing out, start simplifying. So the 2x minus 3 will be crossed out with the 2x minus 3, the 2x plus 3 with the 2x plus 3, the x with the x. So what will be left for us in the simplest form is x minus 3 over x minus 2. How about taking another example? Let's take another example. In this example, the question is asking us to simplify this function n of x in the simplest form and to show the domain. The first thing we do is we do what? Yes, we factorize. So the first numerator can be factored. Yes, it can be factored as s minus 1 squared. And the denominator, it's x minus 1 multiply 2 x squared plus x plus 1 divided by x minus 1, and this one cannot be factored more. The domain in this case, before we simplify, the domain is all real numbers except, yes, except 1 odd. Let's now go and simplify. Keep the first fraction as it is. Change division sign into multiplication sign and then flip the second fraction. Remember it very well. Keep, change, flip. How to simplify it more? You will see that one of these x minus 1 will be crossed out in here, another one will be crossed out with this one, and this one will be crossed out with this one, so it will be equal to 1. Okay, let's see another example. In this example, take care, it's multiplication. In the multiplication, we don't make keep, change, flip. In the multiplication, we multiply numerators together and we multiply denominators together. Okay, so let's now go and try to simplify. In this example, the first numerator we have can be simplified as x minus 6 times x minus 6 or x minus 6 all squared over, I can take x as a common factor, multiply 2, 4 as a common factor, so it's x plus 6, and down, yes, it's difference of 2 squares, so 6 minus x times 6 plus x. And now, before you start simplifying, you need to find the common domain. So the domain in here is all real numbers except, yes, except what? Excellent. Negative 6, 0, and 6. Let's now go and simplify. First, fraction. We write it. And now here, as you can see, in the denominator of the second fraction, it's 6 minus x. Is there a way that I can make it as x minus 6? Yes, just we take a negative outside and change the signs inside. 6 plus x is the same as x plus 6. Let's now simplify. Cross out numerators with denominators if they are identically the same. So x minus 6 with x minus 6, another x minus 6 with x minus 6, and x plus 6 with x plus 6. So what would be left is negative 4 over x. One more example. In example 6, it's division. Let's factorize first the first fraction. X minus 2 and x minus 1. Excellent. Yes, as you guys said, difference of two squares, 1 minus x and 1 plus x, divided by, we take 3 as a common factor, and here the two brackets are x minus 5 and x minus 1. Before we simplify, we find the domain. So the domain in this case is R, except what? Excellent. -1, 1, and 5. To simplify it now, you make the keep, change, flip. And this one, we can make it as x minus 1 by taking a negative sign outside. Keep the first fraction as it is. Change multiplication sign into, change division sign into multiplication sign. And then we flip the second fraction. So here, you can cross out the x minus 1 with the x minus 1, the x minus 5 with the x minus 5. And what will be left for you is that in the numerator, it's x minus 2 times x minus 1. And here's the negative sign. And then down we have 3 times 1 plus x. This is my final answer. This is the expression or the function in the simplest form, and the domain is written. One last example. Let's move on to the exercise. Question 1. The simplest form of the function f, where f of x is 3x over x plus 1 divided by x over x plus 1 is, and the domain is. If you check it now, we'll do, yes, this is division of fractions. So what we do is keep, change, flip. Remember, before you cross out, you need to find the common domain. The domain in this case will be x cannot be -1 and 0 because the second denominator. If you want to simplify this, x plus 1 would be crossed out with x plus 1, x would be crossed out with x, so the answer is 3. So let's see it together. Yes, the simplest form is 3, where the domain is R except -1 and 0. Question 2. If the algebraic fraction x minus a over x minus 3 has a multiplicative inverse of x minus 3 over x plus 2, then what is a? As you know that the multiplicative inverse is the flipping, right? So, as you can see that x minus a is equal to x plus 2. In this case, a equals -2. So, a equals -2. Last question. If f of x equals x squared minus 49 over x cubed minus 8 divided by x plus 7 over x minus 2, find this function in the simplest form, identify the domain, and then find f of a. If you're going to simplify this, x minus 7 times x plus 7 over x minus 2 times x squared plus 2x plus 4 divided by x plus 7 over x minus 2. The common domain in this case is r except for the 2 and the negative 7. To simplify this, keep change flip, keep the first fraction as it is, change division sign into multiplication sign, flip the second fraction. If you want to simplify this, x minus 2 with the x minus 2, x plus 7 with the x plus 7. What is left for you is x minus 7 over x squared plus 2x plus 4. Last part is to find f of 1. We go to the simplified one and we substitute x by 1. So it's 1 squared times 2 times 1 plus 4. So the answer is negative 6 over 7. By finishing this example, we came to the end of our session. Thank you very much and good luck.